All right, this is the Math Models Unit 2 review video. I'm going to go through the study guide like I've done in the past and give you solutions for each of the problems and kind of talk you through kind of what you need to know, what's important. First of all, you've got vocabulary here. You definitely need to study these vocabulary words and definitely would review the properties, like what you see here in number 7, for instance, or number 6. You need to know those properties in kind of basic terms and be able to recognize them in an equation or in like an example. So definitely you need to be studying that. There's a document in the classroom resources that you can use to study for that. Everything else here you should recognize from the lessons and the quizzes and stuff. So make sure you have that stuff well documented. So I'm going to jump over to starting with number 8. I'm going to jump over here so I can draw and write and solve these for you guys. We talked about this during doing the lessons, but this is a bit of a mix. Like this unit has a lot of information. So we're going to be focusing on what you're going to see on the test. So there will be some things that covered in the lessons that are not going to appear here because they're not going to be on the test. So these are the things that you're going to see when you go to take the test. So first thing we have here is a Pythagorean theorem problem. We should know that. We should recognize that by the fact that it says hypotenuse and right triangle. So we know we're dealing with Pythagorean theorem. So we could draw a, underline those a little closer. We could draw a triangle to represent this. It says that the legs are measure of 3 centimeters and 11 centimeters. So that's the first thing you need to know, obviously, is that where the legs of a right triangle are. So that would be the legs, and then we have our hypotenuse, and that is usually represented by the letter C. And so that's what we are trying to find. We're trying to find the measure of C. Obviously, the formula for the Pythagorean theorem is one of the key pieces of information you need here. The formula is a squared plus b squared, where a and b are the legs, equals c squared. So we're going to start by plugging in everything. A is going to be 3 squared. B is going to be 11 squared. And those add up to c squared. Move up here, and 3 squared is 9. 11 squared is 121. Again, that equals c squared. Continue working this out. 9 plus 121 is 130. And then the final step of the process is to take the square root of both sides. You should remember that. And so c equals the square root of 130, which we can use the calculator to find. And it's about 11.4. So you could put that as your answer as well. C is approximately 11 point, what was that? 4. So either of those answers could appear. I'm not sure I remember on the test, but I'm pretty sure the answer appears in decimal form. So 11.4 would be what you were looking for that type of question, the rounded answer for the decimal. So again, that's Pythagorean theorem. That will be, make sure to include that on the formula chart that I send out for the test. All right. Next one. If a 6-sided die is rolled, what's the probability of rolling a 4 or 5? This is a basic probability question. If you remember, in a probability, we have the denominator is always going to be the total number of options. So how many different things might we get if we roll a dice? Well, in this case, there are 6 possibilities. Actually, call that possibilities. Let's erase that. So the denominator is the possibilities. What are the different things we could get if we roll a dice? And then the top is the success, meaning what do we want? Well, we want to roll a 4 or a 5. Well, we know that these are the numbers we could get if we roll a dice, and we want to get 4 or 5. So that's 2 options out of 6 options. And then all we have to do from there is reduce that fraction, if possible. This fraction can reduce to 1 over 3. And so 1 over 3 should be the answer. Now, you might not be sure how to do that. If you're not, if you struggle with simplifying fractions, go over to your calculator and do 2 divided by 6, get the answer, and then hit the button here with the fraction symbol, and it changes from decimal to fraction form, and you could see that it reduces to 1/3. And that's pretty much it. So again, reminding you that for probability, the top of the fraction is what you want, the successes is what we call that, and the denominator is the possibilities. Similar idea number 10. Bag contains 22 red, 17 yellow, and 35 blue marbles. What is the probability of pulling out a yellow marble followed by a blue marble if you replace the yellow marble first? Okay, so first thing we need to know is what are the total possibilities that we could get here? Well, so we add up 22, 17, and 35. And we get, let's see, 14, 74 total options. So the denominator of my first fraction is that there are 74 options, and I want to get a yellow marble. That's 17. So first thing is that there's 17 out of 74 chance of getting a yellow marble. But then I'm going to draw again. And so the second probability is the chance of getting a blue marble. And then there's this phrase, if you replace the yellow marble first, which means there are still 74 marbles in the bag. And I'm going to draw blue. There are 35 blue. And those are my two fractions for the probability. And since I want to do both of those things, I have to multiply those fractions to get the answer. So you can just type this into the calculator if you'd like and get the fractional answer that way. So 17 divided by 74 times, let's see, I got to make sure I don't make that mistake, hit over, okay, times, and it was 35. 35 divided by 74. Multiply those two fractions, and if I change it to a fraction, I get this really crazy fraction, or I have a decimal answer of 0.108, or rounded, it would be 0.11. And again, the fraction was something pretty wild, so we'll just leave that out, but it was 595 over, put that 595 over 5496, which I'm pretty sure on the test you're going to be looking for answers in decimal form. So just so you're aware, this is what we're going to be looking for here. All right. Let's jump to some more problems. I'm going to run through all of the graphing problems and then come back and do some of the other ones. So let's jump into each of these. It says here, if you were to translate the coordinates of f using the vector -5, 6, what would the coordinates of the new points be? Remember that when you're looking at a vector, the vector is telling me where to move on the x and then where to move on the y. In other words, where to move horizontally and then where to move vertically. So negative on the x means to move to the left, positive means to move to the right. Y, positive means to move up, negative means to move down. So this says to take point F here and to go -5, that's going to be 1, 2, 3, 4, 5, and then up 6. 1, 2, 3, 4, 5, 6, right there. So that's -5, +6. And I end up right there, and that is the point -5, 0. And so that would be my answer. The other way you could have done that is you could have taken the actual number for the point F and done math with the number and the vector. So what I mean by that, so you can see what that looks like. This over. I can see here that the starting point for F is 0, -6, and then we're going to add the vector of -5, 6, 0. That makes -5. -6 plus 6 makes 0, and so you can see that's what we got here. So either way works. Just what you prefer, visual or doing the actual math. All right. This is even more basic. They just want you to name the points. number 18 on the practice test. So again, to name the points, you find the x and y coordinates. Start with point D. D has a value of 5 on the x, 5, and then -6. So that's how we're getting that. Point E has a value of, on the x, -7, +7. And then for point F, it has a value of 0 on the x, -6 on the y. So those are your solutions for number. I'll have to fix that when I go add that. Go number 18. There you go. All right. More of the same. If you were to reflect point D across the y-axis, what would the coordinates of the new point be? So the starting value of point D is 5, -6. That's important. So that's where it starts. And then you should have this in your notes, but here's another version of the same information. These are what you do when you reflect over a particular line. They're telling us to reflect over the y-axis. So it says here that when we reflect over the y-axis, we're going to take the points, make the x negative, and leave the y alone. So that's really straightforward. Make the x negative and leave the y alone. So when I do a reflection here, I end up with make the x negative becomes -5, leave the y alone, that's -6. So that point would be at -5, -6, which is right here. And so you can see that that does look like a reflection along the y-axis for the D. So this would be the new D point right there. That's pretty much it. So you need to use those rules. I would definitely have that or some version for reflection rules in front of you for the test. Let me go and box that so you know that's the answer. Okay. I'm going to keep going with all of the graphing problems. It says here, if you were to reflect point D across the x-axis, what would the coordinates of the new point D? Okay, now we're reflecting across the x-axis. So let's hop over. Let's actually write down point D again. Point D is 5, -6, and we're going to change it. And the way we're going to change it is by reflecting across the x-axis. So we hop over here. We see that reflections across the x-axis has a result of changing the y to a negative, but doesn't change the x. So the y is going to go negative, and the x is going to stay the same. So x is going to stay the same. So we put a 5 there, and then the 6 is going to go negative. It's already negative, so it's going to switch to positive. And so that would be the new point, which is 5, 6. That's right here. And that makes sense. That's the new D because we were reflecting across the x-axis, and that is reflected that way. All right. A couple more examples of these. Now we're doing point D again. This time we're reflecting D across the y = x line. That's going to be important. So D again is 5, -6. And we're going to change it to, so the y equals, make sure I'm right about this, y = x line. That's right here. And it says that we need to just switch the y and the x. Don't need to change the signs, just switch them. So that literally means that this becomes -6, 5. And remember that line, or that point is -6, 5 is right here. That's the new point D. And that's because we were reflecting across this line right here. So you can see how that is a reflection across that line. So you can see what I'm telling you is that you're basically doing these rules. So you need to have those rules in front of you. All right, point E now. Point E was -7, 7. And we're going to change it by reflecting it across the y-axis. Okay, so let's hop over here. Y-axis tells me to do a negative on the x, but leave the y alone. So we hop back over. Negative on the x means I'm going to get a +7, and the y is going to be left alone. So it actually ends up being 7, 7. 7, 7 is right here. That's the new point E, and that should make sense because we were reflecting across the y-axis. All right, so that's it for all those graphing problems. Make sure you kind of have a grasp on that. Now let's jump back over to some of these probability problems and some of these other items on the test. It says here, if you roll a die twice, what is the probability of getting a number 4 on both? Okay, so we want to get a 4 on both rolls. So we're doing another one where we have two different events. So we're going to have two fractions, and we're going to multiply those fractions together. So we know that on a die, we have 6 options. We have 6 options both times that we roll, and we want to get a number less than 4 on both. So remember, the options are 1, 2, 3, 4, 5, 6. So we want to get ones that are less than 4. So we have 1, 2, and 3 are all less than 4. So we can get 3 out of 6 on the first roll, 3 out of 6 on the second roll. Fix that 3. So then if we multiply those, 3 times 3 is 9, 6 times 6 is 36, and then we want to reduce that fraction. So we'll go over here, we're going to do 9 divided by 36, and we get 0.25, also known as 1/4. So I'll write both answers, 0.25 or 1/4. I'm not sure what the answer is going to say on the actual test, but either one of those are good answers. All right. Then it says that, sorry, let me fix this so it's not marking through our other problem. There we go. Okay. The ratio of the number of girls to the number of boys was 6/7. If 2,890 students were present, how many girls and how many were boys? All right. Well, we know the total of our proportion on one fraction is 2,890, but we don't know how many boys there were. So x is going to equal the number of boys. We do know that out of the original number, out of the ratio, we had 7 boys, and the total number was 13. So I made a little bit of a jump there, but I'm taking this fraction 6/7. I'm saying 6 girls. I'm going to move this over here. I'm saying there are 6 girls, 7 boys. Therefore, the ratio has 13 total. That's where I'm getting this number. And then I'm taking the 7 from the boys to make that proportion. Then I'm going to cross multiply. So what that ends up looking like is this. 13x equals 7 times 2890. Sorry about running out of room there, but I'm multiplying x times 13 and then 7 times 2,890. So let's do that. 7 times 2,890. Oops. 890. That's 20,230. So I get 13x equals 20,230. And then to get the final answer, I need to divide both sides by 13. That cancels that out, giving me x equals, and we divide the 20,230, and we divide it by, oops, let's go off of full screen here. Okay, 1 minute, fix this. All right, guys, sorry about this. There we go. Get off full screen. All right, we go over and we do 20,230, 20,230 divided by 13, and we get 1,000. So it doesn't work out exactly, but let's say it's we'll round down, so we can't have a part of a kid, a part of a boy. So 1,556. So we run over here. The number of boys is 1,556. Then all we have to do is subtract from the original to find the number of girls. So we do 2,890, 2,890 minus 1,556, 1,334. All right. Next one is another Pythagorean theorem problem. Find the diagonal length of a square. So we have a square, which also contains a right triangle, as you can see there. The square has a side length of 16 centimeters. So both legs, both A and B, are 16 centimeters. So we're going to use the Pythagorean theorem again. We're going to have 16 squared for both of these. So we go find what 16 squared is. It's 256. So 256 plus 256 equals c squared. Let's bring this up here. 256 plus 256. You use your calculator, but I know the answer is 512 equals c squared. And then, as always, the last step of a Pythagorean theorem problem is to take the square root of both sides of the equation to give me c equals so we're going to go to the next line. We're going to do 512. Oops. We're going to do the square root of 512. And we end up with 22.63 if we round. So what's what we'll do? 22.63. 22.63. And that is going to be our answer. All right. Almost there. Couple more problems. Next one. Mean, median, and mode and range. It should say mode there. Mode as well. You need to just go back and look at these lessons and remember mean is the average. Median is the middle number. Mode is the one that has the most. And the range is the high minus the low. That's my basic summary of that. Thankfully, these numbers are already in ascending order. If they were not in order, you would need to rearrange them so that they were from lowest to highest. You have to do that before you do median. So for the mean, I'm going to add up all the numbers. Oops. 81 plus 81. And let's go do that. 71, 1 plus 78 plus 81 plus 81. There are 4 numbers, so I'll divide the answer I get. Divided by 4. Oops. Divided by 4, and I get 77.75. See, I got 311. Divided by 4 is 77.75. That is the answer for the mean. The median, I look for the middle of the data. I see here that the middle is in between these two numbers, so I have to do 78 plus 81 and divide the answer by 2. That's what happens when there is not an individual number that is in the middle. So we're going to do 78 plus 71, and then we're going to do 149, which is what we got, divided by 2, and we get 74.5. So 74.5 is the answer for the median right there. All right. The mode is the number that appears the most times in the data. It's 81. 81 appears twice, so the mode is 81. You don't have to do anything more than that. Lastly, the range. You do the high number, which is 81, and you subtract the low number from it, and we get 10. So this data has a range of 10. All right, so that's pretty much it for that. You just need to remember those basics about how to find each one of those, and I think you'll be good to go. And then we're on to our last question. It says here, the diameter of a circular table is 3 inches. Find the area. I'll put this on the formula chart for you. But the formula for the area of a circle is pi r squared. But that also means you need to know that the radius is half the diameter. Another way of saying that is that the diameter equals 2 times r. So then you need to first take the diameter, which is 3. So our diameter is 3, and you need to find half of it. 1.5 is the radius. So we just divided the diameter times 2. And so that's the number I'm going to plug into my formula. So the area equals pi times 1.5 squared. So we'll go do that over here. Let's go to our next line here, and we find our pi value. Pi times 1.5 squared is 7.07 if you round it. 7.07 centimeters, or inches rather. Sorry about that. Inches squared. So I will put that formula for you in the formula chart so you have it. And I think that is all. So please take the time to go over this. Make sure you know how to do each of these problems. Again, this is modeled after the questions you'll see on the test. So if you are able to do these, you will be well prepared for the test. All right.